as I have explained you, so we saw displacement in the last lesson. What is the displacement? The shortest path traveled by a particle, right? From one position to another position with respect to time, right? So you know it is path dependent, and also here everything we are going to discuss in vector position. Okay, what is a vector? It should contain both magnitude and direction. Okay, so you know, so in the last video what we saw, so what I have explained you about in the last video about the vector. What did you see? Resolution of a vector in 2D, right? Then we saw in 3D also. You got an idea right now. So a vector can be resolved into two components like this, right? So xi vector and yj vector. Suppose if you are considering this is a particle's initial position, okay? Let O to P be the position vector R. This position vector can be written as 2D, that is, it is resolved into two-dimensional compounds. R is equal to xi cap plus yj cap. Okay. 3D also you can write. Okay. So if you want to write in 3D, then another axis, z axis will be there. Then it will be x z vector. Sorry, z k vector. Okay. So like this also you can write. So plus z k vector, k cap. Okay. Now here, what is happening? The particle is moving from this position to this position. Okay. Now, what is the initial position? O to P. Now we are going to record the initial position as a vector. Simply in your first lesson in 1D, what did you record? The particle's movement as a distance, only a magnitude. Here the direction involved, so this is the position vector O to P, it is R, right? Then the particle is moving from P to P prime. And then what is the distance now? R prime. Okay, you know the triangle of addition. What is the triangle of addition insist? If you have a free vectors, you need to inverse something, right? You need to make it in a head and tail position, right? The head should meet a tail. Like that only you have to fix. Here there are two starting positions available, right? So you need to reverse any one. Like this. This might be R and then R prime. R is in reverse position right now. So what is the resultant here? The resultant will be R prime is plus vector, R is minus vector. So this is recorded as delta R here. Okay. Is it clear for you? So it is known as this delta R is nothing but it is the displacement. And it includes what is the direction from P to P prime. Okay. And then you know, so let this particle be, what is this particle? Let this particle be some Is it visible to you? Okay, let this particle be at a position of x1, y1, and this particle be at the position of x2, y2. Then what is this delta y now? y2 minus y1. So what is this delta x now? So x2 minus x1. So this is what we call delta R here. Okay. So it is like a slope, kind of slope. Okay. Difference in y-axis by difference in x-axis. So it is explained as a displacement here. So displacement can be resolved into two components or three components like this. Okay. So what is that? R prime minus R, right? R prime can be written as x prime I cap plus y prime j cap minus xi cap plus yj cap. So if you subtract this x prime, I have told you some x1, y1. So for your x you can take like that. Not only x prime and x. You can take x1, y1 like that. So the difference will be here, right? We saw, right? What is delta x? x2 minus x1. Delta y is y2 minus y1. Like that it will be. So next we'll see the velocity. What is the velocity? You know that? The rate of change of displacement, right? That is the velocity. Here also it says, what it says, the average velocity, ratio of the displacement and the corresponding time interval. Right? What is the ratio of the displacement? This is the ratio of the displacement with respect to time. Okay, you know delta R is this one. Right or not? Delta R, delta x by delta t, delta t into I cap and delta y by delta t into j cap. What is delta x by delta t? That is the velocity Vx. Okay, so why this bar, like it shows it is an average. Okay, it is an average. That means it talks about the position of a particle from initial to final. You are taking an average from initial to final. You did see the particles in between, particles position in between. If you see this particle position in between, there are a lot of positions you can able to differentiate, right? But we are not concentrating on the in between position. We are taking from the initial to the final, so that the resultant will be like an average. It is indicated by this bar. Always we usually put this bar for a mean, average. You have learned from statistics, right? What is this V bar? Delta R by delta T. In your book, the block letter is given. Okay, in CBSE books, the block letter, it represents the vector. But you can't even write in your exams like block letters which represents the vector. But for that, you need to write like this, V vector. You should denote the vector as this arrowhead, okay? On the top, you need to draw an arrowhead. So Vx arrowhead I cap plus Vy arrowhead j cap. Like this you need to represent. Get it? Then, so I've explained yesterday for 12th standard students. You are also with, right? So what is instantaneous velocity? What is instantaneous velocity?
Velocity at the particular range.
Yeah, very good. At that particular instant, at that time, okay, at that moment. So instant. Instant means at the moment. So that is also I have explained you in STEM chapter 1 and chapter 2 concepts. Do you remember that? Suppose if you are moving from your place to here or here to your place, okay, it will take 20 minutes. Okay, so 8 to 8:20 you will be reaching your home from an academy. So you are starting from 8 o'clock and then reaching there into your home by 8:20. So in between, if you want to check, okay, exactly at that time, 8:10 for example, definitely you can't check your timings exactly accurately at 8. Definitely it will be less than 0.00001 or it will be greater than 0.0001. Can you able to understand? It will be 7.999, 8.9999 second or 8:10 for example when it reaches to that, or it will be 10 point something 0001. Okay, is it clear for you? Can you able to understand? So if you want to see the time, it won't be exactly the same. See, for example, what is the average velocity? So this is V average or V bar you are talking about. So delta R cap or R vector by delta T, right? So this is the time change. Okay, you know the initial time and the final time. There is an average between initial and the final time. So there is a definite time period. As I told you, from our academy to your place is 20 minutes, right? So for an average velocity, you are talking about 20 minutes, right? The displacement is the distance. What is the maximum distance? Say for example, 2 kilometers or 2000 meters. Okay, so it is the average velocity. What is an instant velocity? At the particular time. That means you are trying to say delta t is equal to 0. If you put delta t is equal to 0, exactly 0, then what will be the velocity now? Anything by 0 will be 0. Anything by 0. What is anything by 0? It is undefined. Anything by 0 is undefined. Got it? Clear? So it is highly impossible to find out the velocity. It is undefined. So that it is not possible, as we have discussed in Heisenberg's sensitivity principle, right? Once a particle cannot be located and its velocity cannot be measured simultaneously. Right or not? What is that? Heisenberg's uncertainty principle. So what is the reason? What is the problem? There may be small change, quite a bit small change. You can't locate the particle. So if you look at it, so the time period, if you want to see at around 8:10, for example, you won't see exactly at 8:10. It will be less than 10 minutes. That means 0.001 less or 0.001 greater. Like if you want to see the time period at 8:10, okay, so it will be plus or minus 0.0001. For example, I'm saying. Okay, there might be small change. So what is the meaning? There also the delta t exists, but it is negligibly small. So we can say delta t is approaching to 0. Can you able to understand? So that we are setting the limit. The limit is for an instantaneous velocity. What is the limit? This is instantaneous velocity. Limit delta t tends to 0, delta r by delta t. Okay? The scientists gave another notation for it. What is that? dr by dt. Instead of writing limit delta t tends to 0, delta r by delta t, they have given another notations. What is that? Delta r dr by dt, that is instantaneous velocity. Is it clear for you? Okay. See this? What is the direction it is given, right? So P to P1, P to P2 and P to P3 and P like this direction of P. So it is given and then it is discussed over here. P1, P2, P3 represents the position of the object, right? After times. So delta T1, delta T2, delta T3, T4 like that it is recorded. Here initially they didn't include any time period. Here they have included time period in it. It is not shown here, but they said. So P1 is the position at time delta T1. P2 is the position at time delta T2. P3 is delta T3 and so on like this. Okay. As I told you, it is dependent on the path, right? That is very important. So it says, then what it says, it is very important point. This average velocity is parallel to the line tangent to the path. Okay, this is the path, right? This blue color, it indicates the path. Okay, what is the line? If you want to draw a tangent like this indicates the average velocity, the direction of the average velocity. Okay, the tangent only indicates, we saw, right? So what is in a parallelogram law of vector addition? What is in a parallelogram law of vector addition? What we discussed in parallelogram law of vector addition.
Fixed vectors will draw a diagonal.
Okay, now what is the thing you find out from it? The resultants?
Root of a square.
Direction? Yeah. What is the root of a square plus b square plus 2ab?
Magnitude.
Cos theta. That is the magnitude. As well as the direction. Direction conforms tan theta, right? Tan theta only. That is the tangent of an angle. Tangent of the whole thing, right? So you did the same like here also. The tangent of the curve represents the direction of a average velocity. You'll be definitely asked from your test, okay? Sometimes reason assertion also they will be pointing this. Okay, the tangent of the curve represents the average velocity. direction of the average velocity. Got it? Okay?
Ma'am,
Yeah.
so when I say math first 3 chapters.
Yeah. First 4.
Ma'am, just this determinants.
Yeah.
And then relations also.
So relations and then inverse. Inverse result. Okay.
Thank you.
Okay. So that is explained over here. This is very important point I said, right? It is given as a block letters in your book also. Okay, this is very, very important. Have a look at it. Take down all these things. This is very important point. So while note it down, you have to keep in your mind. This is very important. Keep in your mind. What it says, the direction of velocity at any point, okay, on the path of an object. I told you no, so it is path dependent. Really it is path dependent. So it is tangential to the path at that point and is in the direction of motion. Is it clear? So then we move on to this. What it says, the velocity is dr by dt. What type of velocity it is? Instantaneous. Very good, Sanjay. So it is dr by dt. Okay, and then you know it can also be explained like this, right? Limit delta t tends to 0, delta r by, see like this, limit delta t tends to 0, delta r cap, r vector by delta t. So instead of writing this r vector can be written as delta x I cap plus y j cap. Is it clear? Got it, mom? Okay. Then, so this is, you can introduce limit initially to the respective terms. Okay? So you can do multiply inside and then it is individualized. So what is the resultant now? So limit delta t tends to 0, delta x by delta t will be dx by dt. This will be dy by dt. This is nothing but vx and vy. So we can represent the velocity as root of vx square plus vy square. This is the magnitude. So how can you express the magnitude of a vector? How can you express the magnitude of a vector? Like this. You are going to learn math also this year. So v suffix x I cap plus v suffix y j cap. So what is the magnitude? Magnitude is root of the coefficient of I cap square. That means sum of the squares of both the coefficients. Okay. So you need to take the coefficients of I and j. Okay, and then square and sum. Okay, and then put it in the square root. So this will give you a magnitude. So it is the magnitude of a vector. And then you know what is the remaining. So here we can say tan. Tan is nothing but it shows the direction. So tan theta means, you know, if you construct a right angle triangle, you know Vy and Vx. Vy falls on the opposite side, Vx adjacent side. So tan will be opposite by adjacent. So Vy by Vx, right? So tan inverse. So average velocity also they wrote for an average velocity, average acceleration. For an average acceleration, what is that? You know, rate of change of velocity. Okay, so delta V by delta T, it is again represented like this. Okay, like this. This is nothing but it is Ax, Ay. Got it? It can also be write in terms of displacement. Okay, so that is double differentiation. Okay, so acceleration is represented in terms of displacement also by taking double differentiation. You know what is acceleration? Rate of change of velocity. What is velocity? Rate of change of displacement. So you can directly connect this acceleration to displacement by double differentiation. I've told you know what is the differentiation, like a slope you can take. Difference in y-axis by difference in x-axis. dy by dx. Okay, what is dy by dx? It is a kind of differentiation. So I will teach you about differentiation in the subsequent math classes. Okay, then it is easy for you to pick it up. Is it clear for you now? So d square x by dt square, it shows the acceleration along the x direction, and then d square y by dt square, it shows the acceleration along y direction. Got it? Then do listen. I am teaching each and every line from your book, so go through it properly. Parallelly you can learn. Okay, it is easy for you. So then this and all, you know, it is a curve representation of the acceleration, and then you know the x component will be cos theta, right? Right? So how can you freeze this, that and all? I've explained in that video, right? Do you remember that or not? It's a right angle triangle. It shows this is the point P. It is the curve traced by a path. Traced by a particle. Then what happens? The particle is here. This tangent shows what? It is the direction, for example. Or you can take, it is the particle's movement. And then here you draw parallel to x-axis and parallel to y-axis. So it is Vxi component, Vyj component. Okay, if you want to find the particle, so where the particle is, the particle position is, the particle point, the point might be x comma y, right? So what is x, what is y here? So if you want to take this right angle triangle, what is cos theta? What is cos theta now?
Cos theta is equal to
V
Vx I vector.
Because adjacent side, right? Vx by V, right or not? So if you multiply this, what is Vx now? V cos theta. Is it clear? So what is V? What is sin theta here? Here, opposite by hypotenuse. Hypotenuse is the 90 degrees opposite, that is V. So Vy equal to V sin theta, right? These two are all the points. So this is actually totally, the magnitude is V cos theta. This is V sin theta. If you see the particle's point is V cos theta comma V sin theta. It is traveling like this. You want to locate the point is V cos theta comma V sin theta. Sorry, V, correct, X component and Y component. How can you plot a graph X comma Y points, right? Like this. Then here also we will talk about the instantaneous acceleration. You know, if time limits delta t is equal to 0, delta t is approaching to 0, not is exactly equal to 0, that might be negligible difference. Okay, so delta t is approaching to 0, then you know, right, all these things. It's clear for you, right? So it is also representing the triangles. So see the curve, this is an acceleration curve. Acceleration curve is deeply rising, right? So double differentiation of x-axis. Okay, that means x means displacement we are talking about. Okay, velocity is smooth curve, you know, right? It is the deep curve it is given. Okay, is it clear for you? Right now? What is the difference? The difference will be delta v here. For a velocity, the difference will be delta r. Got it? Displacement and velocity. Okay, so here also you can able to find in this what is given, the velocity and the acceleration of an object are always along the same straight line. Okay, that is in the either in the same direction or in the opposite direction. So what they mention, either in the same direction means like this also, or one might be in the opposite. That means same straight line. So how it will be? Same straight line. Like this. If it is acceleration and velocity. Okay. However, for motion in 2 or 3 dimensions, velocity and acceleration vectors may have an angle between 0 and 180 degree. If it is 0 means it falls on the same. Right? Velocity and acceleration. The angle between velocity and acceleration is 0 now. If you have like this, yeah, it is acceleration velocity means it is 180 degrees. Got it? So this is the possibility of discussing about both velocity and acceleration. What does this problem shows? It is very important. The position of a particle is given where t is in seconds and the coefficients are the proper units for r to be in meters, right? Okay. That means they are saying r is the position vector in terms of with respect to time they wrote here. Okay. So you are asked to find the velocity with respect to time. So in your math and all you have learned the function as function in terms of x in algebra, right? F of x, g of x, like that. Here all the functions in terms of time period we are taking. So v of t, a of t, everything you need to find out. Is it clear? So find the magnitude and direction also of v of t at time is equal to 1 second. So they specified some time. At that particular time you are asked to find the magnitude and direction of velocity also. First initially we need to find the velocity and acceleration. Before that I will explain you about a small details for differentiation. Otherwise you can't able to do this. Okay. So I have explained you, right? So we saw in equations of motion. Do you remember that formula? What is that formula?
X power n.
Index.
Very good. Yeah, x power
N is equal to
X power n is equal to
n
x
power
into
minus
n
n into x power. Very good, Sanjay. Right. So this and all you know. Like the same we are going to do here. See, what is r? R is given here like. So this is r. So 2D or 3D?
3D.
3D. R is in 3D they gave. Okay. So what is velocity you know? Rate of change of displacement is velocity. Right? So what is the displacement given here? This is. Okay, you have included it. So here you don't worry about all these things. What is the variable with respect to t? T is the variable. So there is t, where around t here? In these two, right? This is treated as a constant term. Okay, I have told you already if you want to differentiate the constant term, how can you write the constant term like?
X power 0.
Very good. X power 0, right? That means if there is 3 here, okay, or 5, 5 here. How can you differentiate 5? You need to treat this 5 as a constant term. So 1 into 5 you can take d by dx of this 1 can be written as x power 0. Since there is no, what is that? Variable in it. So you need to take this variable as anything per 0. Anything per 0 is 1, right? So it is taken as x power 0. So how can you differentiate this? This 5 is common, taken as common. What is this? 0 x power 0 times. So 5 times 0 into anything will be 0. So this term if you differentiate it will be 0. You can differentiate individually since there is plus sign inside. Okay, in between there is plus sign. You can differentiate individually. How you can differentiate this t? 3 is taken as common. If you differentiate t, what is the result? D by dt of t means t power 1, right? So 1 into t power 1 minus 1. So 1 into 0. 0 1. T power 0. That is equal to this is also 1. So 1 into 1 will be 1. So here it is 1 plus that I cap that will be here. Then 2 into t square, right? So you need not worry about 3.0, 2.0, 5.0. Okay, just 2. Then what is t square? How can you differentiate? D by dt of t square? Yeah, 2t power 2 minus 1. So 2t. So 2t j cap. So 3 into 1 is 3 I cap plus 4t j cap plus 0. Right? So it is given here. This is the velocity. If you want to find the acceleration, you have to differentiate again this thing. Okay, in it, this is constant term, it will be 0. This will be, if you differentiate t, it will be 1. So the resultant will be 4 j. Right? So acceleration will be 4 meter per second square along y direction. How they represent here y direction?
J.
Very good. So here it says j, right? So j vector means it says. So I've already explained you. I kept j and everything in the previous video. So what it says? No. What it says? What it looks like? Axis. Okay. So you have drawn a graph, right? In your graph, each and every graduation is in centimeter. Like that, here also, every every x-axis is divided into I-axis. I1, I2, I3, I like that. Y-axis is J. 1J, 2J, 3J like that. Okay, is it clear for you? Then, you know, right? Then how can you find the now the first part is over. Okay, V of t and A of t we found. What is the second part? At time t is equal to 1 second, you need to find the magnitude and the direction. At time t is equal to 1 second. Okay, first you can find the magnitude. What is the magnitude? The coefficient, the sum of the squares of the coefficients of I and j, and then take a root. Clear? 3 square plus 4 square. So 3 square is 9, 4 square is 16, so 25 is there, root 25 is 5. Is it clear? Okay, then what is the direction? You know, right? Tan inverse of 4 by 3. So you don't worry, you will be given as a hint in your exam. Suppose you are not given any logbook or tangential ratio, there is a table for it. So from that table only you can able to find out tan inverse of 4 by 3 is 1 point something, right? It will be coming. So you can't even find out by means of any other mathematical methods. That is the table in it. Okay? You will be given as a hint, or else you simply leave like this. Okay? The answer will be like this. Got it? So then. So what is the motion in a plane with constant acceleration? What is the meaning of constant acceleration?
Acceleration, uniform.
Uniform acceleration or constant, right? Uniformly it is. Wherever the particle is moving, it suffers with, it experiences the same acceleration. Okay? So what is it explained now? So that means acceleration is constant, right? So what is constant? So over an equal interval of time, the average acceleration will equal this constant value. So what is that constant value now? A is equal to v minus v naught by t. Constant acceleration we are talking about at some initial value at, the time period is start from the rest or something. Okay, if it start from the beginning, that will be 0. First time, that will be recorded as 0. From that only you are counting how the particle is moving. So v minus v naught, and then from this only the first equation of motion came. Right? V is equal to v naught plus at. Where v is the final velocity, v naught is the initial velocity, and these are all the components here. So this is the first equation of motion we have already seen. For this also we can write, if you write the vector notation of the first equation of motion, then you can write in components also. Get my point? So do learn properly all these things. We are going to see projectile motion, which is very, very important. In it, you need to concentrate this vectorial representations along the x-axis and along the y-axis. Two components we are going to discuss in that particular projectile motion. That is very, very, very important, either for your board exams or JEE or NEET or whatever it might be, all competitive exams, as well as if you go for your higher education, that means engineering degree, any engineering degree, this will be very, very, very helpful to understand your core subject. Okay, this is very important. Projectile motion we'll see in the subsequent video, subsequent lesson. Okay. Is it clear for you? Okay, then what is this? What is R minus R naught? you know the average velocity, right? So this also we have learned. Where we have learned? Hmm? So how it will be? How we can achieve this? Average velocity. Do you remember that? Ah. So first what did you do? S is equal to ut plus half at square. So this will be like, instead of u in your book it is given v naught t. Got it? So initial velocity, if you put 0, then what will happen? S is equal to half a t square, right? So what is the first equation? V is equal to, okay, v naught plus at, right? So what is here now? Suppose if you keep this, don't put this as 0, we can keep like this, okay? Okay, what is A here? V minus V naught by T, right? So can we substitute in it? In the place of A, we are going to eliminate this A, okay? In the place of A, what is this? V minus V naught by T into T square. So 1 T gets cancelled. So you'll be having V naught T plus half Vt minus half V naught T. And in, for you also I taught you this, right? In order to eliminate acceleration, suppose if you are not given acceleration, you are given only velocity and time, but you are asked to find the distance or displacement. Okay, then what is the resultant? In the first lesson you talk about only distance, right? Distance or displacement. Here in a vector notation we are seeing, that's all. So this displacement is, what is this? Plus V naught T minus half V naught T. What is this? Plus 1 minus half. What 1 minus half is?
Plus half.
Plus half. So plus half V naught T, right? Is it clear?
Yes.
V naught T minus half V naught T. So 1 minus half is half. Okay, so half V naught T plus half Vt. So what are the common terms you can take outside? And then what is S now? Half V naught plus V into T. So otherwise you can write V naught plus V by 2 into T. Can we write like this? So what is this distance? In a vector notation it will be R minus R naught. Can we express like this in a vector? Is it clear for you? How it comes? Is it clear? This is the displacement vector, R minus R naught. Okay, in your book you might have seen, instead of this S you have written X minus X naught or X1 minus something, X minus X naught only, right? Do you remember that?
Yes.
Okay, here it's a vector, so V R minus R naught, so here it is given V plus V naught by 2 into T, or else in the place of V you can write V naught plus AT also you can write. So these are all the different forms you can able to understand the vectorial representation of all the equations of motion. One is given as an example here. Can you able to understand this? Okay, it is an average velocity. Okay, so average velocity can be written in the form of equations of motion also. Keep in your mind, okay? There. See, based on this it is given what we have discussed here. I have told you, no, x minus x naught also you can take. Same way, y minus y naught also you can take. Okay, in the place of r minus r naught, they have substituted the components, x component and the y component. Okay, so 2D and 3D also you can able to understand. So constant acceleration along two perpendicular directions, right? So what are perpendicular directions? X direction and y direction. Mutually perpendicular. All the axes you are taking is, if you take 3D also, x, y, z, three axes are mutually perpendicular, orthogonal together. Okay? So I told you now, we'll see this in projected motion right now. Huh? So can you see all these examples? Okay, you can see this example and come. take it as a homework assignment. Then, what is the relative velocity? We have seen relative velocity. Velocity of A particle with respect to B particle is Vb minus Va. Or velocity of B particle with respect to A particle, that is Va minus Vb. Everything you know, right? Okay. So what is this? A relative to that of B is given here. Everything is in a vector, that's all. So this block letter, it represents a vector. So but magnitude is same for both. Right or not? So that was proved in our first lesson. VAB equal to VBA. That is proved, right? Go through it. Okay. Since the magnitude is same. See, from your home to our academy, suppose for example 2 kilometers the distance. From our academy to your home also the same distance. Magnitudinally it is same. Okay. But the direction is changing. And the path also changing. Displacement may be varied. The shortest distance. Sometimes it might be one way. So the one way leads to circular path also. It won't be helpful for your shortest distance. So it is different based on so many criteria. Okay? Is it clear for you? Then this rain problem it's very very important for you. So what is given? Rain is falling vertically with the speed of 35 meters per second. Okay, listen carefully. Based on this, I will give you so many problems. Okay, so rain is falling vertically with the speed of 35 meters per second. Then a woman rides a bicycle with the speed of 12 meters per second. So two velocities are given, right? The velocity of rain and the velocity of women with the bicycle. Then in east to west direction, they said. What is the direction? This is the direction chart. You know, right? East, north. You can fix first. Right side is east, top is north. Remaining opposite. Okay? Then, what is the direction in which she should hold her umbrella? That is the question. If she hold her umbrella very straight, definitely she may wet. You could have experience in your day-to-day life also, right? Based on the velocity of the rain, the umbrella should be in some angle. You have to hold your umbrella in some angle. Okay, that we are going to find out. So what is given here? What is the rain velocity?
35 meters.
So both are moving now. Both are having velocity, right? So the rain velocity is taken as VR. What is VB? The bicycle's velocity. Like this, okay? The resultant they have taken as. Okay? What is the resultant? VRB. So that is taken as in the negative direction, right? VB is taken now in negative direction. Why? Why? The velocity, they said the rain is falling straight vertically with some velocity. Okay? You are riding with the bicycle here. The rain falls down. Okay, where you are riding? So here only, right? Like this. Okay? Is it clear for you? Now you have taken this and then. So in order to find the resultant, you need to reverse the velocity, right? You need to reverse any one vector, right or not? This vector you won't reverse. You can't. Right? Because the rain falls vertically, then only it may hit the ground. Okay, so that you are reversing this direction. The head and tail should meet, right or not? Is it clear? If you take here, then you need to solve with the parallelogram law of vector addition. If you take this, then it simply shows the third side of a triangle of addition. You can make use of that, right? You need not worry about the cosine law, sine law and everything. Is it clear? You can directly take VR minus VB. Can we? Is it clear? So in order to solve this in a using triangle of addition, we are just reversing another direction, the bicycle's direction, and then you are getting the resultant in the third side of a triangle. Okay, that is VRB is equal to VR minus VB. Is it clear? Then. And then you know that, right? What is the direction? Always it is tangent, right? Tan theta is equal to VB by VR. Everything is given. Okay. So tan theta is equal to 0.3343 it is coming. As I told you, without table you can't even find the angle or degree. Okay. So that you can simply write tan theta is equal to 0.343 or theta is equal to tan inverse of 0.343. Okay. Is it clear? Okay. So that means what it says? Women experience the velocity of rain relative to the bicycle only. Right? That means with respect to the difference in two velocities. Okay. So we'll see about the projectile motion in the next class. See you. Bye bye.